Hi, folks. Thanks for joining in. Hope you are doing great and, most important, staying safe. I'm Prabhas Sirivadana from WSO2, and this is our 38th Silicon Valley IA meetup. Today, we have Patrik from the Keto project to talk about Keto, which is an open source implementation of Google's Zanzibar. Uh, I learned about keto from a Hacker News thread and thought it would be a very interesting topic to discuss in this forum. So I invited Patrik, and thanks a lot, Patrik, for accepting our invitation. Patrik is based out of Munich, Germany, and he's been contributing to open source projects since 2017. And his academic focus lies in security, distributed systems, and formal languages. With that, I'll hand over to Patrik. Over to you.
Thank you very much. Hi, I'm Patrik. I will introduce you to Keto, the first open source implementation of the Google Zanzibar paper. I assume many of you are here because they heard of the Zanzibar paper and might be interested in the topic in general. I shortly want to introduce you to Keto as a project and what we do at Ory as an open source company. So we started the company out of an educational nonprofit in Germany. And we wanted to build an application that was solving authorization, authentication, and all the problems that come around that. It is now called Hydra. But we soon realized we don't want to build yet another monolithic application trying to solve everything. So we started to break up the service into multiple services, each with its own focus and problem to solve. So our design philosophy for our own open source products is we do everything based on the 12-factor design. We have API first services, so all of our services are headless, bring your own UI. So also Keto is based on all of these principles. We have a single compiled binary with minimal dependencies, minimal size. Speed is a very, very high priority for us. So just that's basically everything Keto is also built upon. Right, so now I want to give you a short introduction to Zanzibar, as not everyone might be familiar with all the details. So Zanzibar is a project by Google, or a paper by Google. They published in 2019. It's a paper about their internal authorization service. And it supports and powers all kinds of Google services, including Calendar, Cloud, Drive, Maps, YouTube, you name it. So as you can imagine, all of those services have very different data models and permission requirements. You might have to explicitly share an object, like a digital object, a video, photo, calendar entry with a specific person. You might have it for everyone in the company. You might share it with anonymous users using links only. So it has to, the authorization system has to be very flexible and meet all of those cases. So be very general. Also, it has to be very fast and always available. This is due to the fact that the authorization is on the critical path of each and every request. It basically adds to the latency of every request. It adds to the latency of, it might add multiple times because if you have a request that requires scanning multiple objects, say search, you might want to apply authorization checks to all search results or all objects that are considered during search. So you might need many authorization checks just for a single client request. And the best authorization system is just never noticed by a regular user, right? So they don't feel the overhead, they don't experience any errors, it just works as intended, and the UI reflects all the permissions they actually have. It also had to be very consistent, so false positive are fatal, like users do stuff they are not allowed to do. Even if the service does not have critical data, that's like a fatal failure anyway. So that's never a good thing to happen. And then also false negatives are at least annoying for the users if they're just time bound. But they can also be fatal if important tasks cannot be done. So consistency here is a very critical and very important goal. Then what also Zanzibar had to solve was just operate at Google scale, which quote unquote means trillions of access control lists, millions of authorization requests per second. So writing a system that just can operate with all the data load that you have at Google scale is hard enough. Meeting all the other requirements next to that is just way harder. You have to have distributed access all around the globe, so you can't afford round-trip times that go across regions or even across continents, as the latency would be just too high just from the round-trip time, not even regarding the actual evaluation of requests. So requests have to be handled locally, but still follow consistency and all the other requirements. So how did Google achieve all of these things at once? They did start with a very basic data structure, the so-called relation tuples. These are two examples for relation tuples. You can easily translate them to English sentence if you just read them from the back to the front. So the first one means John can access cat.jpg, which is a file. So it's in the file namespace. The first thing is the namespace, then we have the object, then access is the relation, and John is the subject. So this is a very straightforward relation between a single user subject and a single object. Then we can also have more complicated relation tuples because instead of a subject ID, we can also have a subject set. That's the second example. So we have the example means basically everyone who has access to the directory cats also has access to the file cat.jpg, which is also very straightforward to just say. And it also makes sense to have permissions defined in this language. And that's everything that relation tuples can do, either have a straight subject ID or a subject set that consists again of an object and a relation. So this is then accompanied by so-called subject set rewrites. They are defined globally in the namespace configuration. So for each namespace, you have configured all the subject set rewrites, and they can basically be used to either automatically add tuples. So for example, if you have write access, you automatically have also read access, which would be basically just 2 times the same tuple, but replace write with read. And the other case is where it gets more complicated than just adding more tuples, is where you have rules similar to you can access a child if you can access the parent. So this is basically just expressing the relation between 2 objects, and needs some further computation to go on and can't be just simply added by relation tuples. Or another good example is that you can only access some file if you are an admin, so you're in the admin group, and you got the explicit permission to do that thing you want to do. So that might also be a rule. So only admins that got the permission can in fact do certain things. So the subject set rewrites are currently not implemented in Keto, but they are like the next big thing we have to do because they're very critical and they are required for many features to come and many integrations that users want to do. But more on that later, what we have and what we don't have. So maybe if there's any questions to like Zanzibar ACLs, or now I will continue, but you can just ask questions to that. It might be like I might hurry some things or.
Yeah, Patrick, one question. So does it
Yes.
support like negative permissions? For example, this says access. Can you also say deny? And if it supports both, then how does it like resolve conflicts?
So the subject set rewrites allow you to basically also do Boolean operations with certain relation tuples. So you can say, like the one example I said, you have to be an admin and you have to have the explicit permission, otherwise it's rejected. Or this can also be a not, so it can also have an exclusion. So you could, for example, ban a user that was, I don't know, like if you explicitly block a user on social media, it can write to everyone except to you. So that's probably would be solved by something like that. So yes, subject set rewrites cover that as well. You can explicitly deny access or.
So for example, we have people says like, so if you belong to a bar group, you can access it. At the same time, if you define another one says for the same object, like if you belong to foo group, access is denied. And we have a subject who is a member of both the groups. Then how does the system resolve that conflict?
So how this actually is implemented is still like we're still in the ideation phase on all the implementation stuff because it's not done yet, but it will be it will be possible, and it's certainly possible as of a kind of language and access control list level. So maybe I can just give you a continue, and then some of the questions might be more clear that we just had, because I wanted to show you how we interpret relation tuples to actually evaluate them and evaluate access checks. So we can interpret relation tuples as a directed graph. And what this means basically, so here we have the two relation tuples included. But we also have, like, I just added some more relation tuples just to have a bigger graph. And in this example, we see that John explicitly got access to the cat.jpg file. And we see that cats is a parent of cat.jpg. We can also see that the subject said everyone who has access to cats has access to cat.jpg is also encoded in this graph. And then you see this dotted line, which is what you resolve the cat's access subject set to, which is in fact Peter, because Peter has access to the cat's directory. So what we do for all of these computations that we have to do about those relation tuples is we use graph algorithms to actually traverse this graph of relation tuples. And we can use graph algorithms very nicely because they're well studied and very common. So usually if you study computer science and if you know the algorithms, there are like standard algorithms, we can easily apply them to those relation tuples. What's also very important is that we so for example, the ACL check would be equivalent to just checking the reachability of a certain node. And here we can also, for the question we had on like negative lookups, basically what we do during the traversal would be on a negative one, we just exclude this path that we're traversing from further traversal, or other Boolean operations might require multiple paths to evaluate to true to actually have the whole request evaluate to true. So what's very nice about the whole graph thing here as well is that in a typical application, you would have a very clustered graph and a very partitioned graph. So it's here I separated the object region and subject region. And you can neatly see that all relations go from the object region towards the subject region. So we have a certain structure within the graph. And because of the clustering, so usually around objects, you would have the same permissions, and you would usually, when you traverse the graph, because you have this clustered structure and the overall structure, you don't have to traverse the whole graph. So you can, whenever you start inside of a cluster, it's very unlikely that you get outside of the cluster. And therefore you can have a graph that contains trillions of nodes, but still evaluate a request within milliseconds, because it's a very limited, very local search within that graph. So maybe some other question came up during that.
No, Patrik, I think we can move.
Okay. Okay, nice. So the next thing that Zanzibar gives us is Zookeys, and this is basically everything around consistency. If you have a background in distributed systems, you might have wondered before how Zanzibar as a distributed system can actually achieve all of those requirements we had, because research and theorems show us that all of these requirements are in conflict with each other. So usually you can only satisfy two or a certain number out of all of them. So if you want to satisfy one, you can't satisfy the other one. But that's only true if you consider all data that are in the whole system. But for data that are fully propagated throughout the system, we can in fact have consistent and fast responses that are always available at the same time. So this just leaves us with the problem, how do we determine if the data have propagated fully? And in Zanzibar, this is achieved using the so-called Zukis. They can give, they encode an object version, which is, so object always refers to a digital object like a photo, or can be really anything that you want to. So the relation, the Zuki always refers to a certain object version, and it's the timestamp of that object. You might also from distributed systems know that clock synchronization is very hard. And for Google, it was actually not that hard to implement because they just have GPS in all their data centers and use that for clock synchronization and get a very high precision of clock synchronization all around the globe. So yeah, that might not be the way to go for an open source implementation, you might think. More on that later though. So we then have to store this object version, so the Zuki, next to the object and provide it in every request. So every time the object is, so access to the object is checked, we have to include the Zuki. And we then can give the system a way to determine if the data have propagated or if the data are at least recent enough to answer this request. So basically each node in the system can determine if it has locally, if the caches and all the local data it has are recent enough to answer this request. And if it can do that, which is the case in most applications, so or in most requests in the real world, it will have all the data it needs because they have propagated within seconds around the globe. Then it can just answer the request, and if it cannot, then it takes some latency to resolve and propagate all the changes. So what this actually means is that, so this whole concept of Zukis means that if a subject previously had a permission on an object, then it might still be able to access the old object versions it already had access to, but it will never be able to access newer object versions than it had access to. So if you revoke now access to a certain object, you can be assured that the subject will never see the newer versions of the object, just the ones it already saw. And in most applications, that's fine because you already had permission to do that. So you might, for example, have anyway a digital copy or done things already. So it just takes this propagation delay to ensure you also don't have access to the old versions anymore. And then the other thing is when a subject newly gets a permission, it might temporarily not have access to previous object versions it did not have yet access to. But all new object versions, it will always have access to. This is basically also the second guarantee of the Zuki concept. And this also just is during the propagation time, which depending on how you deploy and operate the system, usually is just within seconds or the most some minutes. So both of these limitations are by design chosen to be something that's not either not noticed by users or that's not very bad if it actually happens. And now to the practical implementation in an open source project where we can't rely on Google data center features. We do have some ideas how we can actually achieve the same guarantees, because we don't actually need the real-time timestamp, but we can also use logical clocks, and we can use them, for example, based on Bloom filters to allow variable amount, like counts of nodes. So you can change the number of nodes, but still keep a logical clock. So these are some ideas that we have. We don't have anything implemented yet, but we are very positive that we will find a good solution. Google just took whatever they already had and could use, so they took real time because they just had real time everywhere. It's just the easiest thing to do for them. But for us as an open source project, we will have to seek out some new ideas that we can use. So maybe if someone in the audience has some background and maybe some ideas how that could be achieved, it would be very nice to just join the discussions on GitHub on that. Right. You will find the links then later in the description. So,
Patrik, you want to take it now, like related to this slide?
No, I think that's more a discussion thing that can go on for the next days, because it's going to be very complicated. But maybe some questions arose during the last few minutes.
Yeah, there's a question on like what happens to the updates to the old version.
So that depends on the application. Usually you would just, I mean, depending on what object you have. If you have a text document, you might store all the versions. If you have like photos and you just added some metadata or whatever, and you just overwrite stuff, then the old version might be completely lost. But everything is stored within the application itself and not within Keto or Zanzibar, because it's basically used like, I mean, the word Zuki comes from a cookie that we all know from the web. So it is basically just transferring some state to the client to not have all the versions that are stored, that would be stored in the system itself, but the client and the application that's using the authorization server has to store them and provide them later on.
Sure. There's another question. Are cookies optional in an authorization step?
So the Zukis are not, like in the API of Zanzibar, they are not optional, because Zanzibar is globally distributed and is required to run everywhere. So it is required to have this basically staleness bound to know how long it might take for an update to be propagated, and if you can use your data. So in Zanzibar itself, Zukis are required. So currently, as we don't have them implemented, they are not required, obviously, because you can only run Keto as it is now in a single location and not in a multi-regional operation mode. So if you have only a single region, then you only have a single database that's always going to have the most recent data. And in that case, you can always use the most recent data, and you don't need all those consistency guarantees and ideas that are required for the distributed system itself. So yeah, we are, as so many actual applications that might be using this service might themselves not be a distributed system. So in that case, it is completely optional and can be just everything. If everything is operated locally in one region and using always the latest data, then they can be optional. But for a distributed system to have the consistency guarantees, they are always required.
Sure. There's another question on OPA. Do you want to take it now or we'll take it later?
Yeah, we can take it now.
Okay. So the question is, how is it different or similar to OPA?
Open Policy Agent itself has this whole language around you can match strings to different patterns. You can do all kinds of things that you might do, like logical operations, to write your policy, which is very nice to have, but it's very hard to evaluate during runtime. So if you have high throughput and you have a lot of those rules, it does not scale the same way as a very simple data model that does not need any runtime evaluation does. I'd say it just solves a different kind of problem. So we don't think that like OPA is a bad solution or whatever. It just is not going to work in this distributed, globally spanning way, but it will be a very nice addition to have in certain scenarios, in certain applications. So yeah.
Can we say like OPA talks about like defining policies, but I think Zanzibar, in addition to that, it also talks about like the persistence layer and how you like distribute these the objects that you store in the persistent layer and do caching and those stuff too. Like in addition to just defining a policy, like in addition to defining ACL, it also talks about the storage of ACLs too, Zanzibar.
Yeah, so in the paper, they just say that they have tables for each namespace and stored the tuples. I mean, I can just go back to the tuples here. So basically, namespace would be the table name or mapping to a table name. Then you have the object column, the relation column, and the subject column. And this is like a very easy format to store in a database, and it's very easy to manage later on. This is also what we did now, but I will come back to the learnings and to the things we might improve on the persistence layer later on. But yeah, in the paper they describe it just as the relation tuples themselves are stored in the database just as the single columns.
Yeah. There's another question. I have a large set of users. I want to write RBAC like a system. I want to write a RBAC like system with Keto. Would subject that rewrite avoid the issue adding tuples for every user ID? I would like to write some global rules around a user namespace.
Yeah, so for that, there is like a big issue, ongoing discussion we have around having native RBAC support. That's like work in progress, and we are collecting ideas around that. But subject set rewrites will definitely allow you to do that very easy and with less overhead. But I will come to that later as well, because we're thinking about having some high-level APIs for example, to implement RBAC on top of the ACL. But yeah, more on that later.
Okay, so maybe the last question. Are these rules, tuples evaluated and authorization enforced locally rather than round trip to get the decision and enforce?
So the tuples themselves just consist of strings, and the strings are never interpreted in any way. So you just have the three, so object, relation, and subject string, and those strings are just matched to, so basically if the string is equivalent, then Keto thinks the thing you talk about is equivalent. This means that you can basically store anything inside of the relation tuples, and you don't have to stick to the typical examples that we have here. But one very important thing and one very important rule is that if you want to update your stuff, then it can be very tedious. So what we actually recommend is that you have a UUID instead of objects and subject IDs. And you just define in your application a mapping from whatever you have to the UUID. But again, as everything is just strings, and strings are not interpreted in any way, this whole system of relation tuples is very flexible and can be used for all kinds of applications, as you just store whatever you need in your string.
Sure, I think we can move forward. Thank you.
Okay. Right. Then the current state of Keto. I talked about all of that quite a bit already. So we only have a single node operation mode. You can scale horizontally, of course, if you just deploy more nodes, but there is no inter-node communication going on. All of those things that are described in the paper will be added as we go. So we first wanted to get in touch with the whole data structure with the relation tuples to learn about how they can be used and interpreted. So you can use all the read, write, check, and expand APIs as described in the paper. They all worked just with the, one single exception is the rewrites are not there, so you can't express all the things as you would like to do. But as said like 10 times already, subject-set rewrites are going to be the next big thing to work on. Also Zookeys, as we want to have a distributed system and not locally operated system. So we have to figure out some way to determine the order of events there. Then also native ABAC and RBAC support. That's what I was referring to before. So we are thinking about having some high-level API that will allow us to have ABAC, RBAC implemented on top of ACLs, so on top of the relation tuples, but without having to mess with relation tuples yourself. So this will enable you to just use RBAC, but also to just add relation tuples. And everything internally will be expressed as relation tuples, but can then be managed through a higher level API. So we have ideas for that and how that can work and how that is technically possible. That's one of the next big things to also work on and think about. Then we want to provide a lot of integrations with the wider authorization ecosystem. This especially also includes Open Policy Agent, because as I said before, it is very nice in some ways and in some applications to have all these expressive rules and this expressive language, but it does not scale as well as we would like to have it. So just combining both and having the best of both worlds will be very nice and very, very nice feature to have. So we really want to enable some integrations. We also have ideas for that. So one of the biggest things as well is enabling all the caching and the cluster mode that's described in the paper. So we have to add local caches for each node. We have to add consistent hashing to distribute the load across the whole cluster. We have to enable inter-cluster communication. There are a lot of things described in the paper around that. And we want to implement all of these things as well. We have a community member who actually also wanted to work on Zanzibar open source implementation. And he basically took the other way around and started with a multi-node operation mode and worked its way towards implementing Zanzibar as well. So we have some nice feedback there and some prototypes that we can be inspired by and maybe get some ideas from. So, in general, how did we get to all of this current state that we have? We announced the deprecation of the previous legacy open policy agent-based Keto early on. We really wanted to use all our channels to get in contact with the community and determine the best steps to take from there. And unfortunately, we don't have a migration path yet, but we want to enable integration of the one I said with the wider policy ecosystem. This would also include then the old Keto itself. So we want to have an integration there to enable migration by slowly moving from the old system to the new one. Then another thing, it was very important for us to transparently document all our work. So we did not want to sit in our basement, write the next version, and then just push it on GitHub. But instead, we created issues, we started discussions, we asked people, and we reached out to everyone we knew who was using the system, who was interested in the new one. And we then got a lot of valuable input and contributions from our lovely community. So here again, thank you all very much who worked on this, who gave input and who responded, who gave all their time, who jumped on a call and went through all the details, who wrote like this long messages on GitHub and comments about certain topics. And yeah, we just really love all of your effort that you put into that. So thank you all very much. It was not just a single person working on this, although Git suggests, like the Git history suggests that. But in fact, all the ideas were always discussed with multiple people, and all the feedback from the community was very valuable for us. Thank you all for that. We also noticed that the idea behind Zanzibar is very minimalistic. So I just, before the talk, checked. Our check engine implementation is 39 lines of code, which is ridiculously small. So we see that this data structure is not only minimalistic, but it is also minimalistic to implement. And because of that, it is very flexible and can be extended in many ways, as it does not give you any specific directions to go and use this. So then our open source foundation. So of course we did not build everything from scratch, but we used other open source projects and products. All of them listed here. I just wanted to give you an overview of the most important tools and things we use. And we are also very grateful to have all of these nice projects out there that we can build on and we can use to build our products and projects. So the first learnings we had now after I think it's now 1 month of a first alpha release, is that the relation tuples and the API is really as flexible as anticipated. We got a lot of ideas from the community, how it can be used in various systems, also from our own experience in our SaaS cloud production system. We just noticed it does anything we need. It does fit all the needs, anything we can come up with, we can just implement using this basic structure, and it will be very important, and it will enable even more things once we have the subject-set rewrites. So again, this goes through the whole talk, I guess, but the subject-set rewrites are very important and are very much needed for anyone. So next big thing to work on. Also, we learned that gRPC and REST interfaces are both valuable. Just from integration point of view, it's nice to have both of them. It's nice to just be able to curl your way and debug stuff, but it's also nice to have a very dedicated, very fast API for these critical APIs. And also we learned that databases are good at handling huge data tables and can have problems if you have a lot of small databases, as a lot of small tables with just a few entries. So that's the change I was referring to in the persistence layer. We are thinking about moving towards a more merged style of persistence layer, where we just have one table with all relation tuples, where the namespace would be just another column to add. But that's just an idea, and we have to evaluate that and find out all the pros and cons of each and every approach you can take there. So that's definitely not a set topic right now. Also, we learned that relation tuples are not straightforward to design and to grasp by everyone. So like for me, I worked on this half a year, just full-time, implementing Zanzibar in Keto. And at this point, I'm just thinking in relation tuples all over. But for other people, it might be just in the first sense, it might be very hard to grasp the concept. So we want to add a lot of visualization tools there. We have ideas how we can basically use this graph that I showed you before to visualize the relation tuples and to make it clear how the data you have work and how they impact what responses you get from the APIs. So we will hopefully have a lot of nice features and nice visualizations there for all of you to get started and get creative. So here is also my link collection. You cannot click that in the video, of course, but it will be available in the slides later on. So it's everything you find on GitHub, some documentation, our community Slack, where you can reach me personally as well. Also my email if you want to reach me. Yeah, and now I'm here for your questions and discussions.
Yeah, so there are two questions on the so this is very cool. Okay, question is authorization perhaps in the form of authorization token.
Sorry, I did not understand that well.
Authorization can.
Sorry, the connection was not that good here.
Yeah, you also hear an echo. So the question is, are the authorization decisions cached?
So not the so basically partially they can be cached, and they can also be cached as a whole response. The paper, like the Zanzibar paper itself, says that they heavily rely on caching on every level. And the nice thing about caching is because we have these Zukis and these consistency, basically the timestamps that we can compare our data to, we can also look if our caches are recent enough, if they reflect all the things that we need. So if we look up in our cache the result and we can see it was at least as recent as the request was, we can just use the cache. So we will never get a stale or wrong answer from a cache, but still heavily rely on caches and also on caches in a lower level. So for example, if you imagine you have groups of users and then certain groups have access to certain things, then the group membership might be cached and taken from cache, but the actual object to the group relation might be taken from the database.
There's another question. What's the current development status of set of rewrites, design, development, testing?
So the subject set rewrites are in the paper described. So the syntax is in the paper described to basically just writing the AST, so the abstract syntax tree as the config. But we want to provide some nicer thing there, and someone suggested on Twitter, like in response to the Zanzibar paper itself, to use a Prolog, so a first order logic language. And I do think that's a very nice idea, but I'm not sure if that's applicable, as there's like no Go Prolog parser out there that we can just plug in and use. But we would have to implement that ourselves. But if we could do that, then we could also use it to evaluate the rewrites themselves. And that would be very nice, of course, but there's no project we can just use. So we will have to look what's from effort perspective the easiest way to go, as well as the nicest solution to take.
There's another question. What's your thoughts on how to build an efficient but authorization aware search over a large number of items?
So large number of items is not really a problem. I mean, of course, that depends a bit on what specifically your data model looks like. But as I said, usually you have in this, if you visualize the relation tuples as a graph, you have them clustered, and searches and traversal only happen locally. So even if you have large amounts of data and items, you might not have to traverse all of them. If you happen to traverse all of them, it will, of course, take a long time. But that's, yeah, a problem you will always have in any authorization system, that if you have to search all data, if you have to search terabytes of data, it will take a very long time.
Yeah, so there's another question from Nick. How big is ORY? How do we support you working on this open source project?
Sorry, there's some background noise. Can you please repeat that?
Yeah, how big is ORY? Is that how you pronounce against your company? Right? How do we support you working on this open source project?
All right, yeah. So Ory is right now a pretty small team. Until now, I'm basically the core maintainer of Keto itself, and the only person very deep into the topics. But a good thing is that we are growing rapidly and fast, and we are planning to have this SaaS offering that I talked about to provide the business background to sustain the development of the open source project. So the project itself will always remain open source. We're working on a way to also legally have that binding and have that defined, to ensure there's never going to be business decisions made over the open source, because open source for us is a very important and a very core value, and we really are committed to keeping all of the projects we have open source, and not rejecting any security features just to monetize them later on. That's very important for us to make clear, and to also keep in our philosophy.
Yeah, so the Zanzibar is using Spanner for like their persistence, right? In your Keto open source project, what's the persistence layer?
Sorry, can you repeat that question again?
Yeah, so the Zanzibar project, so they use Spanner as their database for the persistence. So what's the database or the persistence layer supported by Keto open source project?
Right, yeah. So we use for persistence Go Buffalo Pop, which is an abstraction layer above multiple SQL databases and drivers. So that allows us to use MySQL, SQLite, Postgres, and Cockroach as the main databases. As you probably know, the only one of those that's allowing you to have a cluster operation and cluster mode is Cockroach. All of the other ones can just run in a single node mode, where you have single database. So they can be used if you don't want to deploy your Keto in a global way, but we really think that Cockroach as a distributed database can give us all the features that Spanner has and that Google utilizes from Spanner. to actually have a system that's globally distributed and that can run across clouds and that can be used everywhere in the world. So we, for example, have there some ideas to utilize follower reads, to not have the database to update all queries and all results always, but we can use stale data basically bound to the time encoded in the zoo key. But all of these ideas are, again, just ideas, as we don't have the cluster mode yet, but we know, or we think that Cockroach has the technology to support us with all the things we need later on.
Or anyone can just deploy Keto on top of Spanner?
Sorry, anyone can what?
Deploy the Keto on top of Spanner. Like, can they use Spanner as their persistent layer itself?
So Spanner does not provide the same SQL API that the other databases provide. So we don't have out of the box, basically support. But we are thinking about adding a Spanner specific connection later on. Once we know that the internal APIs are stabilized, because we would need to maintain that as well. And the more individual database layers we add, the more work it will be. But once the internal APIs will get more stable, we will probably also add Spanner support.
You also mentioned that you have plans to have a SaaS offering on top of Keto. Do you have like rough timeline on that? Because I see like so there's a complexity in setting up the persistent layer for a like small company. So a SaaS offering would be ideal for them. Like they don't need to worry about how you geographically distribute the object. So when do you have a rough timeline on when the SaaS offering will be available?
So we do have already a close preview that's not including Keto for customers, just that we use internally. But the timeline is that basically starting tomorrow, I will turn my focus again towards Keto after this 1 month of less focused work. And we will bring Keto to the cloud hopefully as soon as possible. It might require us to do some changes and implement some more features, but that's also good for the community. So the plan is to basically the next month work on that and hopefully have that. The question rather is how long we will have to stay in the closed preview, because as we are quite a small team, we have limited resources and cannot maintain and organize all the things around tens or hundreds of customers, but can just work with a few close customers that we have good contact to. But the plan is to have it next month available, and then the closed preview is more the question when that might be open for everyone.
So I think that's all we have for the question. So thanks a lot, Patrik, and thanks a lot for taking all the questions. And thanks everyone for joining in. And looking forward to see you all in our next meetup. Thank you.